Hey guys, it's Paulo Haddad here, and in today's video I'm gonna show you some of the summary results and explain you how we can run our file, the 13 bus. Let's go to the computer. First thing I would like to do here, guys, before I explain this file and clean that a little bit, I will go back and show you the 13 bus. So let's open our model, and when you open it, you're gonna see three different files. The first file is this one, IEEE 13 node ckt.dss. So it's basically the file I opened in OpenDSS. So it has the circuit element, which is basically the first element that you need to define when you are creating your model. It's the Thevenin equivalent of the transmission, or at the head of your feeder. Then here in this example, we have a couple of transformers and also some hack controls, which are control elements that can be associated to the transformers, and then they operate as a regulator. We also have some line codes, which are general elements, and those general elements help us to define our PD or PC elements. So PD is for power delivery elements, and for power delivery we have transformers, lines. So those elements that basically transports power through it. We also have the PC elements, which are power conversion elements, and we then have generators, loads, PV systems, storages. So it's basically them. We have then here our loads defined. We also have two capacitors in this system, some lines. Then we have something that we are going to discuss, which is set voltage basis and calc voltage basis, and why it's important or not. It really need to be here or not, and when it's here, what it gives us. So we're gonna discuss that probably in this video if we have time. And then we solve power flow. I'm gonna also talk about the mode we have here already. And then we have a bus coords command, which basically loads a bus coordinates. Yeah, that's about it. So if you come back and then you open your IEEE line codes, we have different line codes here as well. So let's see if we are redirecting any file here. So we are not using this file then. I'm gonna talk about that later. And then we have our CSV file with the coordinates. So come back to OpenDSS. The first thing I would like to do, guys, I'm gonna, when you have these or slash, it means that we have comments. I'm gonna delete those just to have a better view of what we have. So transformer define, so then regulators, then I'm gonna delete this. Oh, I'm sorry guys, I told you that we are not using IEEE line codes. Yeah, we are. We have redirect here command that basically brings all the lines that we have in that file into this file. So when we run that, OpenDSS basically runs all the lines we have in the other file. Then later I'm gonna talk about the difference between compile and redirect, but it's not for this video. I think I can delete these. And then what else? So when you have like slash star, and then star slash. It is a section of comment. So in this case here, I can delete all. Okay. What else I have? Loads. Probably I don't need that because we know those are loads. Capacitors. And then I'm gonna delete it. And then we have one switch. And then, yeah, we don't need that. We don't, again, slash star slash, so we can delete it, and you can delete those guys as well. Another way to comment your code is by using slash slash, as you can see here, so you can delete it. All right, so one guy that I'm gonna give a space here is the solve command. I guess I'm not gonna use them right now. Awesome. Okay, so guys, what I'm gonna show you is how we can run your script. The first thing that you always should have is clear or clear all. This is the command we have in OpenDSS. Let's leave the way it was. And then you can, how you run that? You always need to select the line you wanna run, and then you can either right click to select, or you can hold Ctrl and D. Right? You're gonna run that. Same thing you can see here, Ctrl D. Well, you can run, you know, element by element. You can run like clear, and then you can run line by line. Okay. Or you can get like a piece of your system and run that. But be careful. You see that when I'm running the same code, I always consider the clean before. For instance, let's say I clean everything, and then I run that, and when I run that again, OpenDSS will tell me, well, this is something I already have in the model. So always try to clean OpenDSS memory to allow you to run again all those lines, or in other words, the same element. Cool. One thing that I want to show you guys here is in your left we have the summary, and I'm going to show you what's happening here when we go over this file running a couple of lines. So let's start cleaning, and then I'm going to run the circuit element. When I run that, you see that the devices go to 1. If I run now a transformer, devices 2. So OpenDSS is loading it. Now let's run transformer reg control, transform head control, transform and head control. Let's run them. And then we have 1, 2, 3, 4, 5, 6 plus 2 that we had before, go to 8 devices. So we then run transformer, go to 9, and when we run the file with line codes, or even when you run here the line codes, the device's information doesn't change, because those are not devices, those are general elements in OpenDSS. Therefore, here for what we are seeing devices, they don't count. So if I run like loads, you're gonna see that we have devices 9. It goes to 24 because we run all the loads. And you might be asking yourself, what is general elements? So to check the type of elements we have in OpenDSS, you can go to this section above here. You can go and see that we have PDs, PCs, controls, meters, general. If you set general and then you see the list, those are all general elements. And as you can see, line code is there. Okay, so when you have a general element, it doesn't count. I need to check when we have a meter element if that counts. I think it does, but we can do that later. Well, let's do one thing, guys. I'm gonna run all the circuit until So I'm gonna run until the set voltage basis. So we have 38 elements in this model, okay, and then we can see that we don't have buses, nodes, information, and also those total iterations, control iteration that we're gonna talk about in the next video. Anyway, but you see that the only information we can get here is the number of devices that OpenDSS has loaded. Now, if I set the voltage basis and then I calc the voltage basis, things changed. Well, now I see buses and nodes, the number of buses and nodes. There's some results below here, but doesn't look at that now. We're gonna talk about those in the next video. Why now I have buses, the 16 and nodes 41, and also look at this. Now the status of our simulation is solved, but let me do that again. When I Control D until this guy, we just have a status of not solved. And why when I run that, it changed to solved? It's because when OpenDSS calculate the voltage basis, it performs what it calls a power flow direct, which is basically a power flow that doesn't have iterations because it doesn't consider the compensate currents of the PC elements. Well, it's too much here to explain. I will probably do a video showing you the power flow method of OpenDSS. But for now, just consider that OpenDSS does a power flow that doesn't consider all the loads and generators, right? So when OpenDSS performs a power flow, then it needs the Y matrix of the system, and when it builds the Y matrix of the system, then it has the information of buses, number of buses and nodes, because there's the mapping there to know which element belongs to, which bus and node the Y element belongs when you have the matrix. Anyway, it's a long story. We can talk about it if you are interested. Actually, if you are interested, leave in the in the comment section below, please. Anyway, so interesting. OpenDSS shows solved for us, and now it shows the number of buses and nodes. Well, and then if I do the last thing now, guys, if I include a solve command, or even if I go to this button here and click on that, OpenDSS then performs, the simulation that we have set. In this case, as you can see, by default, OpenDSS sets the mode equals to snap. So solution mode equals to snap. If you want a different one, then we need to come here and set mode to a different one. But now OpenDSS considers the snap, and the same thing if you go to set mode equal snap or snapshot. So I can then Control A and D, run OpenDSS, and then we have a power flow results. So guys, what I showed you in this video, how you run line by line your file. If you run all the file, we had interesting redirect command here as well, right? I'll talk about the set voltage base and calc voltage in terms of performing a power flow later. When we go to the voltage results, we're gonna see actually why we do that and what is the benefits to do that, and then we solve a power flow. In the next video, I'm gonna talk about a little bit of the type of results we see here below, the circuit summary, and I will also look at those three guys here: total iteration, control iterations, and max solution iteration, and just give you a little explanation of what that actually means for us. Okay, so guys, that's all for this video. Again, if you like it, don't forget to give me a thumbs up. If you are not subscribed to my channel, please subscribe and hit the bell button so you'll be notified as soon as I upload any new video. I hope you enjoyed it, and I hope to see you in the next one.